Welcome to today's explainer. It's August 25, 2026, and right now there is a massive, multi-million-dollar debate echoing through the halls of almost every major enterprise IT department. We're talking about the brain of your enterprise artificial intelligence. Specifically, how exactly do we feed the right knowledge at the exact right time to a large language model so it can actually help your employees and customers? The architectures being built to pull this off are incredibly sophisticated, but as we're going to see today, they might be entirely missing the absolute most important piece of the puzzle. Okay, let's dive into this. How does an AI actually know what it knows? When an employee asks your internal chatbot a really complex question about, say, compliance rules or manufacturing tolerances, the AI doesn't just magically know your company's proprietary secrets. It has to be fed that information right at the moment it generates a response. Answering this fundamental question has become the central technical challenge for enterprise AI teams today, and it's led to an absolute explosion in data delivery infrastructure. To solve this, two distinct heavyweight architectures have emerged. You've probably heard the acronyms RAG, which stands for Retrieval-Augmented Generation, and CAG, which stands for Cache-Augmented Generation. I want you to think of these two systems as plumbing. They're highly engineered pipes built to deliver a flow of information directly to your AI. Now, they're both trying to solve the exact same narrow problem, getting data to the AI at the precise moment of generation, but they do it in completely different ways. Think of our first system as a highly pressurized set of pipes, RAG, or Retrieval-Augmented Generation. RAG is essentially a search-based delivery mechanic. It separates the storage of your data from the generation of the AI's response. How this works in practice for a user is actually pretty straightforward. When someone types a question, the RAG system hits pause, runs a rapid similarity search across your company's documents to find the most relevant paragraphs, fetches those specific chunks of text, and then injects them right into the AI's prompt so it can generate an accurate answer. It retrieves the data right when you ask for it. Now, RAG has some incredible superpowers, but they come at a steep cost. It literally takes all your source documents and converts them into mathematical representations called vector embeddings. Because it runs these similarity searches right at query time, RAG is absolutely ideal for unbounded, massive datasets that change frequently. You update a file, RAG can find it immediately. But, well, here's the catch. To make this all work, you need highly complex chunking pipelines, massive embedding models, and heavy vector databases. It's a massive infrastructure footprint to maintain. Because RAG is so complex, a challenger emerged, CAG, or Cache-Augmented Generation. If RAG is all about searching at the last possible second, CAG is all about preloading everything ahead of time. CAG takes advantage of the incredibly large context windows and native prompt caching features available in modern LLMs. Instead of searching around, it just loads the whole library up front. CAG completely flips the script. Its mechanics are practically the opposite of RAG. During what we call a warm-up phase, CAG formats your documents into one giant block of text and processes it. It saves the model's internal computational state, the key value cache. So when a user asks a question, the model answers directly from that cache state. It trades a heavy upfront loading cost for lightning-fast, incredibly cheap per-query responses. It doesn't even need a search index. That makes its infrastructure much simpler, which makes it absolutely perfect for stable, frequently read knowledge bases, like an employee handbook or a static compliance archive. Now, what's really interesting about this structural showdown is that IT leaders treat this as the ultimate infrastructure decision. Do you want immediate data freshness, but you're willing to accept higher latency and complex vector databases? Well, that's RAG. Or do you want very low latency and simpler infrastructure, but with data that goes stale until you manually rebuild the cache? That's CAG. The entire tech industry is treating this as the ultimate either-or decision for enterprise AI. But here's the massive blind spot that almost everyone is missing. Notice what neither of these systems actually checks. If your underlying source file contains a typo, an unreconciled revision, or a process that changed on the factory floor but was just never updated in the system, the AI doesn't care. A multi-million-dollar RAG pipeline is going to fetch that bad document and give you a perfectly retrieved, confidently ranked wrong answer. A fully warmed CAG deployment will give you a perfectly cached, blazing fast, outdated answer. Both architectures are equally fast at delivering a complete mistake. Which brings us to the real question here. Who actually owns the process? Think back to our plumbing analogy for a second. RAG and CAG are just the pipes. They're brilliant, highly engineered pipes, sure, but they're still just pipes. What we're talking about right now is the water treatment plant. We're talking about the governance of the information itself. Who is accountable for keeping it accurate? How do disagreements between the documented process and the actual physical process get resolved? The real question isn't delivery at all. It's process governance. It's a matter of speed versus direction. The retrieval speed of your vector database and the sub-second latency of your cached context window mean absolutely nothing if the process they are pulling from is unowned, undocumented, or quietly changed by a manager on the floor without updating the source file. Neither RAG nor CAG has a native mechanism to tell you if the knowledge it's delivering is actually trustworthy. They just deliver it. And this is precisely the gap that a brilliant framework called Integrated Process Excellence, or IP, was built to close. Created by John Cache-Augmented and rooted in Roger Slater's foundational 1996 work on process management, IP is a deployment framework that operates one layer beneath your AI architecture. It doesn't compete with RAG or CAG. Instead, it governs the process worksheets, the ownership, and the control data that your RAG system indexes or your CAG system loads in the first place. IPE relies on a strict, self-reinforcing loop. It starts by defining and documenting your process in a positive environment. But more importantly, it forces you to communicate, measure, and continuously improve it. You aren't just writing something down and forgetting about it. This constant measurement and control mechanism secures the process well before that process description ever becomes a chunk of text in a vector store or a preloaded page in a context window. So how does it actually do that? Through the IPE data architecture. Instead of feeding your AI messy, unstructured PDFs that literally no one has read since 2019, IPE replaces them with governed, explicitly owned process records. This architecture breaks everything down causally into key input variables, key process variables, and key output variables, KIV, KPV, and KOV, all structured hierarchically by area, activity, and element. Because this data is explicitly owned and tracked, it actually informs the AI when the source material needs to change. Let's look at how this directly supercharges our two AI architectures. If you choose RAG, IPE means your system isn't chunking some random policy PDF. It's embedding governed worksheets that already carry a defined owner and current control limits. If you choose CAG, remember its biggest weakness is not knowing when its cache is stale. Well, IPE's governance dictates exactly when that preloaded context is actually outdated enough to warrant rebuilding the cache. The continuous improvement loop in IPE provides the absolute missing feedback mechanism for both frameworks, catching changes before they ever surface as a wrong answer to an end user. So the crucial point is, it all boils down to one simple philosophy: process first, tool second. The IP framework does not replace RAG, it doesn't replace CAG. It makes them trustworthy. The process documentation layer absolutely must be defined, owned, and controlled first. Only then do you choose your retrieval or caching tool second, basing that decision entirely on your data's volatility and scale, safe in the knowledge that the data itself is fundamentally sound. Now, I know some of you are probably thinking, well, my enterprise team is building a hybrid system. We're using both RAG and CAG to get the best of both worlds. And hey, that is great for infrastructure. But from a governance perspective, you're just creating the exact same gap twice. Routing ungoverned data through two different delivery paths simply creates two independently maintained and potentially highly inconsistent copies of what we do here. This is exactly why the ultimate formula for success is simply data plus process equals AI ROI. By placing an IP-governed layer underneath a hybrid system, you ensure that both the cached static tier and the retrieved dynamic tier are drawing from a single, tightly controlled process of record. Without the process layer, your data is literally just noise, and your AI ROI is going to flatline as users lose trust in the hallucinations and outdated answers. The best news here? Your organization doesn't even have to start from scratch. John Cache-Augmented and IPE services have developed what they call IPE packs. These are sector-specific process intelligence libraries. Right now, there are 81 packs spanning domains like healthcare, manufacturing, pharma, even plastic injection molding. They come with master KPI mapping tables and give you a starting library of pre-structured KIV, KPV, and KOV variables. It's an immediate, governed foundation that shortens the path for any AI knowledge architecture to responsibly draw upon. I want to leave you with this final provocative thought to take back to your IT and operations teams. Is your enterprise AI delivering governed facts, or is it just delivering fast mistakes? Because if you aren't absolutely sure, it's time to rethink your infrastructure priorities and fix your foundation before the first document is ever chunked, embedded, or cached. To start applying the IPE framework to your AI architecture today, you can reach out directly to John Cache-Augmented at johncache@ipe.services. Thanks for joining me on this explainer, and we will see you next time.